Hi everyone, this is about your homework on the exercise 23.1 about vectors, the more question for practice. And this question 3, which is student have some student request uh, for how to solve it, right? Okay, so now this we start from this one, question 3 in exercise 23.1. Because question give us say ABC is a parallelogram. Okay, so and question also say P and Q is a midpoint of AB and AD respectively. Okay, so from this case, P is a midpoint of AB. Then we know AP equal to PB, and at the same time, vector AP equal to vector PB also. Let's now go this direction, okay? Because question lead A, B, C, D, so we have to assign as the word they lead the direction. If you want to go opposite, just have negative side. That's it. And at the same time, come to see Q is the midpoint of AD. Q is the midpoint AD. So we know the length of AQ equal to QD. At the same time, the vector of AQ equal to the vector of QD go the same direction, then we go this direction. Okay. Then we start to form this information because we know A, B, C, D is parallelogram. So we gonna use the formula of this one to do question A. Okay, because of this one. So we start say because of A, B, C, D is parallelogram. Okay, so then we have the formula of this one. Remember from the first formula I explained on a few days ago on in GC, talk about this one. You go to review the first one we talking about, first or second one. Okay, or before we learn before. Okay, but when we know this ABCD is a parallelogram, right? So we're gonna have vector of AB or AD. It's okay, start from there. So you're gonna have AD plus vector of AB. Okay, equal to AC. So we're gonna have AD plus AB equal to AC. AD plus AB equal to vector AC. So then we can draw this line. Draw AC vector. Okay. To destination here, okay, AC. Then the direction is go this way, okay? The direction. Now next, AD, we can, so you can see AD is what? Because we know Q is a half of AD. So we try to get AQ, AP plus AQ, AP plus AQ. So I will say AD is 2 times of AQ. Right? For the length we know because AQ equal to QD. Then vector AQ equal to vector QD. So when we know AD here, AD this direction. Okay. Then we're gonna have we can know from this is that AD equal to 2 times of AQ. Then at the same time, AB is what? Here AB we know PQ also is a midpoint Okay. So we will have 2 times of AP equal to AB. 2 times of AP equal to AB. 2 AP. Okay, equal to AB. So then this one equal to AC. Then AQ, then we get the common factor. Common factor. Right now you observe we have AQ, this is AQ, AP, this is AP. Then you get the common factor throughout. So AQ plus AP equal to AC, vector AC, vector AC. So now divide both sides. So we have a vector AQ plus vector AP equal to half of vector AC. Okay, so now we got it for the first one, question A. So this is a question A. Okay, this ABC, this is a question want us to do. Okay, because I did not like the question down. You have handouts. Then you, when you study this, go back to see the question one more time. What they give you the data and they want you to do. But so far, this is on the board here. Okay, so now we finish the first one, question A. Now we go for question B. Work on the question B. See B here, question B here. We want to find, question 1 are to find PC plus QC equal to 3 over 3 over 2 AC, vector AC. Now you observe, right, PC mean this one. So we draw one line first. We draw the line of PC. We draw this line first, okay, PC. And QC, so we draw this one also, QC. Okay, so now we come back QC, PC, so have to go this direction, arrow here. You see how we call PC, so that the arrow head, the direction have to be in destination as C. Okay, and also QC, so destination should be as C from Q to C. Okay, now we're gonna do this one, question B. Then we can observe by PC, see any triangle which have PC and QC, right? So from this one, PC, we can use this triangle, either PBC or PAC here. Or you can call, according to the letter, you can call ACP or BCP. Normally we call according the order of letter. Okay, so we can use this one triangle at the same time. See QC here, this one QC is right here. So QC we can use either triangle Q, either triangle CDQ or ACQ. Okay, but then I'm gonna use I will use the AC. I will use the AC. I will use this triangle ACB and ACQ because I have the AC here. I want to find AC, so I'm gonna use these two triangles. Okay, so I write down triangle of ACQ. Triangle of ACQ and the triangle of ACP. Okay, I will use these two triangles. So then first triangle ACQ, right? ACQ. So you find out PC Because they start PC first, maybe I like PC first. Can I let this one become P and Q? So I use this triangle first because PC, right? So I'm gonna start from here. ACP, ACP. And second one, ACQ. So I'm gonna work on PC first. Okay. So find PC. We want to find PC. So you use the commutative or the additional of triangle vector, the one. Okay. Use the common point. They have common point. So PC, right? Right now PC. See this one PC. PC. I can have PA plus AC. So I have PA plus AC. The vector of PA and the vector of AC. So you see common point here, AA. So I got PC, correct? Same as this one. Okay, now next plus QC. Now see QC use the commutative law also. QC here, right? QC. So I can have QA plus AC. So I have QA plus AC. You see the common point here, A, right? A. So you got QC equal to this one. Everyone observe? Okay. So now next from this one. This one arrow here, okay. From here. I try to find question B, okay. Question B here. Then PA. From question A, we have AP, right? So from question A, I have AP, but this is a PA. So I can swap direction, right? So gonna be negative. This is a AP, right? AP, but I have this one PA. So become minus a negative AP, vector AP, plus AC I will keep because I will have to make it AC vector. So I keep AC, don't change anything there. Plus QA, you see from the question A we got this is a QA, but we have AQ, correct? So we swap it. So swap. So QA, but I have AQ, so become negative AQ. Plus AC, this one. Plus AC. We don't change because we want AC. Now, negative AP, negative AQ. So we get a common factor negative out, right? Minus AP, vector AP, plus AQ. And then AC plus become 2AC. Okay. And then from this, you can see from the first one, we already find A, right? Question A, AQ plus AP, same here, right? AQ plus AP equal to half of AC here, half of AC. So you write down this on negative side. So become 1/2 AC. And plus 2AC. Okay, now you simplify. Same vector, now AC. So 2, 4 minus 1 become 3. 3/2 vector AC. So from this one we got now. So we get the answer vector PC plus QC equal to 3/2 AC. Question B, we got it. This is a question B. Okay. So now we go next question C. They use almost the same idea, okay? So try to do step by step and try to get from the data they give to us and see the direction, that's the main point, try to see them. direction and use the geometry to help about how many scalar of the each vector, right? Okay, now this is question C. Question C, we use another color, maybe green. Question C. C, question want us to find vector PD plus vector QB equal to 1 over 2 AC. Equal to 1 to AC. Now again, you observe PD and QB where they are. PD or here, right? PD. So you have to draw one line. PD from here. Draw up there. PD. Okay. So now this and what else? QB. QB from here. So you draw the vector QB. Vector QB. Stop right here. So and then draw the direction PD. So the direction should be go this side, right? In destination at D, and QB destination as point B. Okay. So now this how we get. You see this the relationship between two vectors, PD. So can use how many triangle ADP or DCP, right? Have this one PD. So you can use either triangle ADP or DCP. Okay, and QB here. So you see where the triangle, this one, right? ABQ, right? Or can use QBC or BCQ here. Try to see the vector or the length of the vector we want to find and find the triangles. Now we can use we start from PD first, right? So I will use ADP, PD first, right? So I use ADP, triangle ADP. So I write down so you can see. Triangle ADP and triangle what? ABQ. AB for QB, right? Because QB is right here, right? So I will use ABQ, triangle of ABQ. Now we start to work on the left hand side. See the equal this one equal to 1 over to vector AC or not, whether or not. So we start from PD, triangle ADP, ADP here. So start from P, right? P, so we can have PA plus AD. We have PA plus AD. Then you see common point here, AA, you got PD here. Okay, now plus means this one plus QB here. So QB we use triangle ABQ, correct? ABQ. So QB you start from Q. Q I'm gonna use I get QA plus AB. QA plus AB. Sorry. QA plus AB. So you observe AA, you got QB here. AA common point, you got QB. Okay. Now we work on the left hand side. Okay, we work on the left hand side. Okay, then from PA again, sometimes try to see previous information or previous data we have and try to use it. PA, but we have AP. AD. Okay, so PA, right? PA, but we have AP. You see that AP. Okay, because we lead A, B, C, D, so the direction have to be A, B, or AP, or PB. Okay, if you call opposite, then you just like the negative side. That's all. So now AP here, exact or no? We have AP from here, but this one PA, so gonna be negative AB. Okay, plus AD here. AD, we haven't used anything. AD, we leave it in that way first. Plus AD. Try to eliminate this one QA first. QA, see QA, right? But we have AQ, see that? AQ. When we lead AQ, AD, right? But here it's a QA, so it's gonna be what? Negative. So change, undo this. Should be negative side here, become AQ, vector AQ, plus AB, plus AB. Now see AB here. See this one, AB. Okay, this AB is right here, so I can use the I can use this triangle, right? AB. I can use the big triangle here, ABC. The AB can use a lot. Can use ABC. Can use APC. Right? Can use AQC. Can use ADC. But I will use below here because I want to convert to something related to the AP. Okay, so I will use it below because I want to relate it to AP. Sorry. So I have I use a triangle ABC. This one use triangle ABC. ABC. So from AB, right? So you start A. So AB plus, I use AC plus CB. So I have AC plus CB. See this common point CC, we got AB here. Okay. Now AC, we have AC, we have AC, AD. Now you observe this one, AP, AQ, same as the first one, question A, correct? Question A, this one. Or you can see from here the same meaning. We have AP plus AQ, but this one AP plus AQ, AP plus AQ, same, right? So you get a common negative side. Take it out, become AP plus AQ. Okay, so you see that AQ plus AP same as here, right? AP plus AQ. Okay, this I mean this one. Okay. Let's see this one. This and this mean below here. Okay. So now next, AD, AC. Okay. Now we see this because this is CB, right? But we have BC. We have this one BC. And AC, we keep it. Okay, then AD. Okay, you see this AD is equal to BC, correct? Because the parallelogram. So AD, vector AD equal to vector BC. So I change this one. I use another color, okay? So maybe this one. Yellow one maybe. Here. See this AD. AD equal to vector BC. So I write down plus BC. Plus AC. I keep AC. And then CB, right? But we have vector the direction BC, correct? This one go this way, okay? And this one should be the same direction because this is a AD, right? And this is a BC. So, but this is a CB, so become negative BC. Okay. So now plus BC minus BC, this one gone. No more for this. Then we left here, write it down. So this one can be negative AP plus AQ here equal to 1 over 2 AC. So you write down negative 1 over 2 A vector AC. And then plus AC. Next gonna be what? Simplify, right? Become 2. So become 1 over 2 AC. Okay, so now you see this equal, correct? So now you can say left hand side equal to right hand side. Okay, so this is a question C. Okay, so this is a solution of the question 3. Okay, which is some student asked for the solution. But then question 4, 5, 6, similar idea. You do step by step in this way. So I will leave question 4, 5, 6. If you need help again, maybe later. Okay, I want some students try it first because still many students haven't started for this exercise 23.1. The more question here I give to do, let your guy do. So maybe see keep for a while. See today have any response and give your classmates time to practice by themselves. And otherwise I will provide you the next question 4, 5, and 6. But you try first 4, 5, 6. Okay. I give you the answer key or not, have or not. If not, maybe I will give you in maybe in the line. I take picture and give to you. Otherwise, I will post in the material again. You check both way, okay, in GC and the line group. Okay. So now that's all for right now. Try to do list of questions, and if not, I will back and explain again in GC. Just wait for some of your friends. Okay, most of them haven't tried yet. Okay. Okay, I think that's all for today. Okay, thank you. Bye bye. Hi. Okay, next one. This question 4. This question 4. Oh, sorry. This question 4 for exercise 23. Exercise 23.1. Question 4 have some student requests also. Okay, now I will explain how to get the solution. Okay. Okay, when you have handout, right? You bring your handout out. I did not write the question on the board, so you take a look the question from your handout. The question say OAB. OAB is a triangle, and that gives M is a midpoint of AB, and N is a 1 point on OB, such that ON, vector ON equal to M of the vector OB. M is a scalar now, like a K in the formula we learned for the scalar multiplications. Okay. So now question want us to express or find question A, vector AM and vector OM in terms of OA and OB. And question B, find vector MN in terms of OA, OB, and M. Okay, now we do question A first. Right? We do question A first to find AM and OM. So take a look. AM we have here. So AM, right? Because we have question called triangle. Question called the triangle OAB. Triangle OAB. So we go this one OAB. OAB. So the direction this one should be here. OAB, OAB, BO, okay? So direction N is B here. So we want to find AM, we have AM here. M midpoint, right, of AB. So we know the length of AM equal to MB. Then we can apply also, once we know this M is a midpoint, we can know the vector of AM equal to the vector of MB. Okay, once we know this length equal and go the same direction. From this one, we want to find AM in terms of OAOB, OAOB here. So we can, in the triangle of OM, right? We need OM, so we draw this one line. So draw the line OM. So from OM draw down here. Okay. So we have this point, and then we have the direction. The direction go down here. Dot OM. And after this we have OM. Okay, now we can work. We use a triangle of BMO. BMO, right? So we're gonna use a triangle of BMO. Triangle of BMO. And after this triangle of BMO, we can start from AM. And start from AM. I'm trying to write small as I can because I want to squeeze all the question A, B in one page so you can see and compare how to do it. Okay, AM. So I use the triangle BMO. So BMO, if I want to find, we start AM first, right? So can I use this one? I erase this one. I should use the triangle AMO first, I think, because we want to find AM. So AM, we use triangle AMO. AMO. AMO, so we start from AM. So A start with A, right? So we triangle AMO. So AO plus OM. So AO plus OM. The vector of AO plus OM. You see the common factor OO here. We got AM. Okay. So now we have the direction of OA. This is OA, right? The direction OA. Got a question called OAB, OAB. So the direction should be called like this, OAB. So AO, we have AO, but this is OA. So this one gonna be opposite side. So like negative OA, negative OA plus OM. OM here. So I can use a triangle BOM or BMO, okay? So this one, for this one, okay, let me like OM here. OM, I use triangle BOM. B, because from BMO, triangle BMO. Go according the order of letter. So this one gonna be OM, OB. We try to get OM, so we have OB plus BM. OB plus BM. So BB, I got OM. Okay. Now for this one, gonna have this is the same O negative OA. OB we already have it, we keep it because we not want to find in terms of OA and OB. So we keep this one, OA, OB. Then BM, but we have MB, so go opposite direction again. So we become negative MB, negative MB. And after this, we still keep this one right because we have OA already and OB. MB, you see MB because we know M is the midpoint of AB. So MB is a half of AB, correct? MB is a half of vector AB. Okay, so keep this one. Nothing changed for the first two terms. AB, now this AB, we can use the big triangle here, ABO, because why? Because we know OAOB, right? So because we want to make in the term OAOB. So from this one, form AB here, okay? So we're gonna have negative 1/2, open bracket, do the triangle of ABO, triangle of ABO. Triangle ABO. So we start, it's AB, so we start from A. So become AO plus OB. And this one gonna be minus OA plus OB minus 1/2. We have OA vector OA, right? But this one AO. So this should be negative sign, right? So negative sign, negative times negative. This one should be plus OA. This one gonna be plus OA, but this one negative 1/2 times in still negative 1/2 OB. Then you can simplify now. Minus O vector OA and plus 1/2 OA. We left is what we left 2 become minus 1/2 OA. And this OB combined with this one times 2 become plus 1/2 OB. Then you can get the common factor, right? Because we get in terms of OA, OB already, see that same. So get the common factor out. So become 1/2 OB minus vector OA. Okay, so this is a final answer for question A. For question A. Okay, this is a final answer. Final answer here. Now we work for question B. Or not yet, right? We have to find. We get AM only. This is the first one is the AM. This one we find AM only. This one AM. But now we have to find OM. Have to work separately. Now we work for OM now this time. Let me separate, draw some line up here. I put the box down. Okay. So now come to find OM. To find OM. OM, this one here. OM down here. OM in terms of OM in terms of ON, OB also. So which triangle we're gonna use? Can be either one because the M is a midpoint. So maybe I will use BMO, Why? Because I know this side, right? I know ON, NB. At least I know ON here. Okay, I know ON, I know OB. So I will use triangle BMO. Okay, so still question A to find OM, okay? So I use triangle of BMO. This triangle BMO. Then start from OM. Try to get OM, vector OM. OM, so you start from O. BMO, so this triangle. So OB plus BM. So we have OB plus BM. You see common factor BB, you got OM. Got OM. So OB, we already have, right, from here. OB, so we have OB already. OB and BM, write it down, OB plus OA plus AB. OA plus AB equal to OB. Okay, right? If OB is a OA plus AB equal to OB, yes. Now BM is here, but we know MB, right? This one we have BM, but we know MB, so it's the opposite direction again. So this one have to be negative side. Negative side become MB. Actually similar to question A here. See that have MB here. So now keep OB minus MB. Again, MB is a half of AB. Same idea, I think. Half of AB. Otherwise, you can use this data right away. Okay, but anyway, work on this one. AB. So from AB again, right? From this AB, I can use the triangle of ABO. I can use the triangle ABO. Okay, so I have OB minus 1/2 AB open bracket start from A because AB start from A, so become AO plus OB again, right? And so see common factor OO, we got AB. Now OB minus, so we have the direction we have is a OA, but this is a AO, so this should be negative. Negative times negative again, this one become plus 1/2 OA. 1/2 OA. And this is a negative, right? So open time in expand become minus 1/2 OB. Okay. So now this one gonna be simplify now. 1 OB minus half OB left 1/2 OB. minus or plus OA plus 1 over 2 plus 1 over 2 OA, sorry, OA. So if you get the common factor 1 over 2, you will have OB plus OA. So this is the final answer for question A, which is vector OM equal to half of vector OB plus OA. Okay, so we finish question A. Now come to work question B. Now we work on the question B. Now separate this one. Draw one line here first. Okay. Do question B. B, we want to find Mn in terms of vector A and vector B and M. So find Mn, this one. So draw one line, Mn. So M to N here. And the direction should be destination at N because Mn destination at N. So now Mn, what triangle we can use? Can use many, can use MNB, MON, what else? MNO. So I will use MNO because I have some data from why I use NO, MNO because you see I have ON here. So I'm gonna use triangle MNO. So see the triangle MNO. The triangle MNO. So we have what we have. Start from there. Sorry. Vector Mn equal to Mn. So start from M. MNO. So MO plus ON. MO plus ON. Vector ON. Vector MO. OO. So you got MN. Okay. Now MO. But we have vector from the question is the OM. So opposite direction again. So this is gonna be negative OM. Okay, plus ON we have from here equal to MOB. Scalar M O vector OB. Okay. Then OB we keep it because we want to convert in the term of OA, OB, and M. So we keep this one, but we convert this one. Okay, minus OM. OM, we're gonna use the formula of OBM. OM, I will use triangle. The triangle of BOM. BOM. Okay, because OM here, I'm gonna use this triangle. So I use another color. Okay, for this one, OM. OM, I use this triangle. OM, I use triangle BMO. Triangle BMO. So start from O. So OB plus BM. OB plus BM. BB common fact for common point. So got OM plus MOB. Now equal to OB we already have. So time expand become vector OB minus BM minus BM plus MOB. So again, BM similar to this one again, you see that? Because we have BM here and we convert to this, right? We have the vector MB, but this is a BM. So you just, it's the opposite direction. So minus may not become plus MB. Because this one here, MB, but this is a BM. So you swap, right? Swap the direction, become negative, 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 become plus, so MB plus MOB. Okay, so MB do the same thing again from this one. Okay, MB you use the triangle AOB again, MB. MB, okay, like this one. OM plus MB. MB is a half of AB, correct? Half of AB plus MOB. So OB, I mean AB, vector AB here, AB here, right? So we can use the big one here, the largest triangle. So we use ABO. Okay, so we use the triangle ABO. This orange one maybe. This triangle, use the triangle ABO. So this one gonna be minus OB plus 1/2, open the bracket, AB, so AO plus OB, vector OB plus MOB. Now become minus OB plus, we have vector OA, but this is AO again, right? So swap direction. So this one gonna be minus. So minus times plus 1/2 gonna be negative 2OA. And then this already OB, don't need to change anything. So become half of OB plus MOB. Okay, so then OB here, 3 terms here, you can combine, become what? Take the OB common vector out, so you have -1 plus 1/2 plus MOB, right? And then minus 1/2 OA. So this one combine, simplify to this one will left M, I like M first. This one 2 become minus 1/2 OB minus 1/2 OA. Can do anything else more? No? I think that's all for answer. Cannot do anything much. So that's the final answer for vector MN. Okay. So now we finish question B. This is a question B here. Question B. We have the vector of MN in terms of OA, OB, and M here. So this is a final answer. Okay. So now this is a question 4 in these lessons. Okay. So now you take a look. So up to now, question 3 and 4, I think quite clear how to do, because they are similar to work for the question 5 and 6. So you try first maybe if I can edit the date, I will move one more day for let your guy work for question 5 and 6. Okay, that means maybe due on tomorrow. Okay, tomorrow give one more day to work on and try to do by yourself. I really want your guy practice and do by yourself, please. So study again the technique and how to solve the question. Okay, so it's not much hard, so it's only take a little bit time. The main thing, make sure the direction and use the geometry you learned in previous years, like a grade 8, grade 9. Okay, that's like a geometry plus algebra. Okay, now only concentrate on direction. Okay, have to really careful direction. Opposite side, just change to be negative side something. Okay, I think that's all. Okay, and then I will post it later, very soon. I will do it right away. Okay. Thank you. Bye bye.